Today's lesson in air and aerodynamics is we're going to investigate the forces of flight. All right, so there are four forces of flight. We're going to talk about them separately, but the four forces are lift, weight, thrust, and drag. So remember that a force is any push or pull on something. So for example, when you throw a ball, when you pull on an object, when you run a race, forces, they work in pairs and they're going to pull in opposite directions at the same time. So lift, this is a force that pushes upward. That's what allows a plane to fly. Then there's the weight of the airplane that's pulling it downward because of gravity. Thrust is the force that's going to propel the plane forward. And then the opposite force to that is called drag. Drag is the force that's going to slow down an airplane. All right, so the opposite of lift is weight. The opposite of thrust is drag. But those are the four forces we're going to talk about. All right, so here in this diagram, we can see the airplane. So upward force, that's lift. The opposite to that is weight because of gravity. Thrust, that's the forward force. And then the opposite to that is drag. So talking about lift first, I don't know why that looks like that, but it should be spelled L-I-F-T for lift. So lift is occurring because of the shape of an airplane's wing. So it's very important to look at that shape of an airplane's wing. The top or front of the wing, it's more curved than the bottom of the wing. And so the bottom of the wing here, the top is more curved. So the air that flows over the top of the wing, it's moving much faster. So much faster over the top of the wing. It's at a faster speed than the air that's flowing under the wing. So here it's slower air. So the faster moving air exerts less pressure or force than the slower moving air. So therefore the force under the wing pulling down, which is the weight, is less than the force pulling up, which is the lift. All right, so that's the lift, which is going to hold an airplane up. You might have heard the term airfoil. That's the special name for the shape of airplane wings. It's this airfoil shape. It's like a teardrop on its side. And it's always designed that way to create lift. So an airplane wing, it's designed so that air flows faster over the wing than it does beneath the wing. All right, so here, note here, faster air has lower pressure, slower air has higher pressure. So just a little bit more about lift. Lift is a force generated by a solid object moving through a fluid like air. So an airplane needs many parts to generate lift, but it's the wings that do most of the work as the plane flies through the air. All right, so again, it has to do with the wing shape and that airfoil shape. So weight, this was the opposite to lift. This is the force that's pulling on an airplane downward, and it's because of gravity. So when we are trying to achieve lift, lift has to be greater than weight for the plane to ride into the air. All right, so again, weight is that downward direction force of gravity towards the center of the earth. The weight of an aircraft affects how much lift and thrust on an aircraft will be needed in order to fly. Right? And that's why airplanes have rules on how much weight passengers can have in their luggage when they're boarding the airplane. All right, the next force we're going to talk about is thrust. This is the force which is going to move the plane forward. So thrust is produced by a propeller. The propeller will pull the plane forward. or there might be jet exhaust, which will push the plane forward. All right, so we have the engine of an aircraft. It creates the thrust that propels the plane forward. The engine will push air backwards with the same force the plane moves forward. And we'll talk about Newton's law, but it is Newton's third law of motion, which states that a force in one direction produces an equal force in the opposite direction. And the force opposite to thrust is called drag. So this is the force that's going to slow the airplane down. So as the plane moves forward, it's going to have resistance, air resistance and wind resistance and so on. Okay, that's the unwanted force in flight because it's going to force the engines to work harder. Think about like if you ever stick your hand out of a window while you're driving, you could feel air pushing against your hand. So that means you're causing a small amount of drag that affects the car's motion. So to reduce drag and increase efficiency, planes are streamlined in shape, and that makes them more aerodynamic. All right, so drag again, that's what's slowing us down or slowing down the airplane. Think about it when you're walking in a swimming pool, right? It's all that resistance you're getting from water when you're trying to walk in a pool, right? So drag is a force that acts upon an object in the opposite direction that it's moving. All right, so we're going to watch a couple videos here on airplanes and how they stay in the air.
Welcome to Dr. Howe's Science Wows, where I am ready to answer another of your questions. And today's question is, how do planes stay up in the air when they are so heavy? Planes are pretty big machines. The world's largest passenger plane is the Airbus A380, which can weigh as much as 560,000 kilograms. That's a lot of plane to get into the air and keep it there. Even smaller planes with all their equipment and passengers and baggage are pretty heavy things, so how do they stay in the air? We think of air as being really light as we move through it all the time. But remember, air is made up of tiny molecules that can actually be really strong too. There are lots of them, and they can move together with quite a force. Air can be so strong it can blow over people, cars, and even buildings when it's moving very fast, like a tornado. That means air can be strong enough to hold a plane in the sky too. But we don't need to create extreme weather conditions to do this. We just need to consider 4 important forces and get them just right. The 4 forces are lift, gravity, thrust, and drag. These 4 forces act in different directions. Lift pushes the plane up, gravity pulls it down, thrust propels it forward, and drag pushes it back. If we can get these 4 forces balanced just right, we can get a plane in the air and keep it there. Let's consider lift first, and to do this we need to look at the shape of the plane, and in particular the wings. We call the wing shape an aerofoil. It is curved at the top like this. This shape is designed to make air move faster over the top of the wing than below it. When air speeds up, its pressure decreases, and this is in keeping with a law of physics known as Bernoulli's principle. When the air pressure on top of the wing is less than the air pressure below the wing, it creates a force called lift, which pushes upwards on the wing. Gravity is the force that pulls the plane towards Earth. It keeps it on the ground. In order for the plane to get into the air, the lift force needs to be greater than the force of gravity. So how does this happen? To get enough air moving over the wings of the plane, it needs to be travelling through the air at quite a speed. We use engines to propel the plane forward using a force called thrust. The more thrust is generated, the faster the plane goes and the more air travels around the wings. Lift increases until its force is greater than that of gravity and the plane takes off into the air. So far we have considered 3 of the 4 forces, lift, gravity and thrust. There is one more to consider, and that is drag. Drag can be described as a force that acts against a moving object. So in this case, the plane is being propelled through the air by the force of thrust, but that air is moving against it and creating a drag force. Thrust moved the plane forward, drag pushes it backwards. In order to keep the plane moving in the right direction, thrust must be greater than drag. Planes are designed to be streamlined, which means it allows air pass around them with the least amount of resistance to reduce drag. So to recap, a plane can stay in the air once the four forces, lift, gravity, thrust, and drag, are kept at the right balance. Essentially, the plane needs to have no net force acting on it, which means that each of the forces balance each other out. Let's consider one more law, Newton's law of motion. This states that an object at rest will stay at rest, and an object in motion will stay in motion once there is no net force acting on it. What this really means is that once all these four forces are balanced, the moving plane will stay moving, in the air, in flight, which is just the way we like it. A big thank you to 6-year-old Cathal for sending in this question. Got a question yourself? Why not send it on to me? You can email it at drhowsciencewows@gmail.com.
Is human flight possible? How do all those airplanes in the skies above us get there? And what keeps them up there? Let's take a few minutes to learn just how these interesting machines take flight. Understanding how airplanes fly requires us to familiarize ourselves with the forces that act on them as they slice through the air. There are 4 of these forces, 2 artificial ones designed to overcome 2 natural ones. These natural forces are the weight of the plane, or the force of gravity, and wind resistance, or drag, which is a form of friction exerted by different gaseous molecules in air. Surmounting these effects requires forces known as lift and thrust, each of which is delivered by a unique piece of technology found on any airplane. First, there's the heaviest, loudest, and perhaps the most familiar part of the flight experience, the engine. The airplane engine is an engineering marvel all its own. The engine that powered the famous 1903 Flyer, designed by the Wright brothers, featured a custom-built 12-horsepower gasoline engine. It was essentially a powered bike chain that drove twin propellers. Today's turbojet engines are a far cry from their predecessors, weighing up to 8,000 pounds and generating more than 30,000 horsepower. Both, however, accomplish the same job: to provide a force that thrusts airplanes forward on takeoff and once they're in the air. The sheer size and sound of today's jet engines might make it feel like they're doing all the work to get you and your fellow passengers off the ground. But that forward motion is only part of the flight equation. The upward force required to lift the plane into the air is provided by the plane's wings. Here's where the physics of flight gets a little tricky, if only because of a widely but slightly misunderstood conception of aerodynamics. Let's take a look at the cross-section of an airplane wing or airfoil in flight. You might have learned that the curved shape of an airfoil is what gives it the uncanny ability to float upward. Air first diverges at the front of the wing, part of it rolling over the curved section and the rest along the straight edge. Because the distance between 2 points, in this case the front and back of the wing, is a straight line, air along the bottom tends to want to travel faster. So to catch up, air molecules above the wing have to travel even more quickly to meet up with the same air packet that diverged at the front of the wing. Fast-moving air above creates low pressure, while slower-moving air below creates higher pressure. So the overall effect is upward movement. The mechanism seems to make intuitive sense. The thing is, it's not quite right. There is no physical law that dictates that air molecules have to meet up after being carved apart by an airplane wing, but shape does play an integral part in flight. Air tends to want to move in a straight line. The curved portion of an airfoil, however, deflects air such as the same number of air molecules are smeared over a larger volume than those traveling along the bottom edge. This creates a pressure differential, low pressure above and high pressure below. And voila, that creates lift. If you need a little more convincing, try this exercise or think back to the last time you might have tried it. Stick your arm out the window of a moving car and cup your hand. You will feel the physical consequences of adding that curvature with your fingers pressed tightly together. Try creating different curvatures, both positive and negative, and you'll understand how airplane wings also make descents toward the ground possible. These forces are enough to make flight by airplane possible, and while maneuvering in the air is vastly more complicated, it's simply a matter of forcing air to pass over the wings of a plane in different ways. The technologies that enable different movements include ailerons, elevators, rudders, spoilers, and air brakes. Some wing prototypes are even designed to morph organically, like the wings of a bird or insect, allowing for even finer control over flight mechanics. So the next time you're at the airport or hear the roar of a plane engine overhead, take a moment to appreciate all the interesting physics, both simple and complex, that makes human air travel a marvel of modern society.
All right, so the videos talked a little bit about Bernoulli's principle. So Daniel Bernoulli, he was a Swiss mathematician and he worked with aerodynamics. And he discovered that moving fluids exerted less pressure than still fluids. So it also applies to moving air as well, because air is also a fluid. So basically, Bernoulli's principle means that the faster the air moves over an object, the lower the pressure. All right, so faster moving air, lower the pressure. So if we just go back here to this picture, the faster air has lower pressure and the slower air has higher pressure, and that is what is creating that lift. So we're just going to review the scientific method before you try your two activities. So we have start with like an observation or a question. You'd have some research in that area. Then you would form some sort of a hypothesis or a prediction. This is basically, it's like an educated guess of an answer to the question. Then you're going to test with your experiment, analyze the data, report the conclusions. All right, so same thing here in the scientific method. You have your question. What are we trying to learn more about? You'd have some sort of research or information about that topic. Then you'd form your hypothesis or your prediction. That's your educated guess. That's going to answer the question. Then you'd have a procedure or method, a step-by-step experiment to test your hypothesis. Then you'd have your data. You'd analyze your information that you collected during the experiment. You'd have your observations, what you observed during the experiment. And then lastly would be your conclusion. Was your hypothesis correct or was it incorrect?